So there is this result we already discussed. I told you that the expected value of the sum of the draws made at random from the box with replacement proxy box is equal to number of draws times average of the box. That is very clear. So the question is, what is the standard deviation? Right. So let's look at another example and then we will get the formula after that. So suppose you are playing, going to Las Vegas and play something called Keno. Your favorite bet is a dollar on a single number. When you win, they give you the dollar back and $2 more. So you earn $2. When you lose, they keep the dollar. So you lose your dollar. Therefore, your gain is -1. So your gain is either $2 or -1. There is one chance in 4 to win, right? So the chance of winning is 1 in 4. About how much would you expect to win or lose in 100 plays if you make this bet on each play? So it's asking about the expected gain. Right? What is the expected gain? Right? So how do we find out that? In this case, n is 100, right? So you have to find out the box. What is the box that you have to consider? What are the numbers that you should consider? How many of each? And then from that box you can find out the mean of the box. Right? So mean of the box times 100 will be the expected gain. Right? So you have to have a box. The box should have two types of tickets, 2 and -1. Right? So how many 2s and how many -1s?
1, 2,
1
3, minus
3, right? 1 and 3. Because 1 out of 4 is the winning probably. Right. So what is the mean of this box then?
minus
3 times plus 2, that is -1, 0.25, right? Negative. So that's therefore on average in one game you expect to lose $0.25, right? $0.25, that means 25 cents. So if you do it 100 times, $25.
Don't you need to take the weighted average or something? 2 times 1 plus 3 times -1 divided by 4 like that?
If you have a -3, making it on -3, making it on +2, it's equal to -1 divided by 4. Same තමයි. Total එකට මේකේ මේකේ තියෙන වගේ මේ total මෙතන වෙන්නේ. මෙතන මේ ඔතුරක් තියෙනවා මේ තුනේ වෙලික තුනක් එකතු කරලා. Right? හරි. तो මේ වගේ එකක් නැති. එතකොට average of the box is -0.25. Therefore the expected gain is after 100 games is -$25. That means you expect to lose $25 on average, not gaining, right? So I just look at what are the possibilities again. So this is the line with 0.25n, and you can see again when you do it 100 times, there's a high variation. Right? There are large number of possibilities to end up with. So the question is, so on average, right, this is going down. So this is on average after that. So this is 0.25 after on this line, the average line. Right? So it's 25. Right? So 25 will be here. So but actual amount after you play this thing can be any of these. Right? So let's look at this one also, then we'll look at the standard error. Because we are not going to derive anything, just going to take what they say and they give you the formula. Right. If you bet $1 on the single number at Nevada roulette and that number comes up, you get $1 back together with make up Excel in any, right. So මේකෙදි කොහොමද වෙන්නේ? මේකෙදි මොකද්ද? What is the expected gain in this case? We have already looked at the box. Right? So 35 or -1. Those are the two types of tickets. Right? So this is only one here. Is 37 of these, right? 37 of these. So what is the average of the box? 35 minus 37. that is minus 2. Minus 2 divided by 38. You have to divide by 38 to get the average. So the average expected value on the box is going to be negative 2 divided by 38. So you can see that again. That is the expected amount that you get on one play, right? If you do it 1 times. But here they are going to do it 100 times. Therefore, the expected gain is going to be this times 100. This times 100. So again, you can see the expected gain is a negative value. Of course, otherwise people will not have this kind of casinos, right? Casino owners are always winning, not the others, right? But it's not a very big, very big loss actually. Very small, negative 2 divided by 38 on average, right? Right. So it's like drawing from this box. So this is the expected gain after 100 plays, right? Expected gain. You are bound to lose only $5 after 100 games. Right? If you are betting $1 each time, it's not bad also. Right. So we saw that the possibilities are like this. Right? There is a chance of getting a large amount of win after 100 end up here, but that is only one possibility out of very large number of other possibilities where there's a very high chance of ending up here. Most of the lines are ending up below 0 here. Actually, this line is not 0. This is the line that previous one with a very small slope, right? So this is like 0.05, negative 0.05 times n. Right? So it almost like a horizontal line, but actually this is negative 0.05 times n line, right, with a very small negative slope. That is the expected value. Right. One more example. You make it when I'm called out the Andiva. Kaulu Muragi, but you know, I can't stress the board and the very small task. Right, let's look at this one. If you suppose you are drawing 25 rows with replacement from this box. So what is the expected gain after 25 rows? So the mean, you have to find out the mean. So 2 plus 5, 5 is 15, 15 divided by 5, 3, right? So average of the box is 3, therefore if you play it n times, the expected gain will be 3 times n. Here we are playing 25 times, therefore at the end of the 25 games, expected gain is $75. Of course, the actual amount will be around that, somewhere around that. So the actual sum is going to be the expected sum plus chance error. The question is how large the chance error can be, how big the chance error is likely to be. Right. So that is the question that you are talking about all the time. Actually, we use something called the standard error. Standard error of the sum gives you the likely size of the chance error at the end of the game. Right? That's called the standard error. Right? It is actually the same as the standard deviation. Only thing is we are using a different word here. Right? So here, for example, I have looked at only 100 simulations. So if I take this value and some values around here, if I read actually these values, possibilities here, there are 100 possibilities. Now assume that you do it many times more, like 10,000 times, so there will be 10,000 points at the end, right? So if you take those 10,000 values and if you find out the standard deviation of those values, right? When you have a list of numbers, you know how to find out the standard deviation. That is what we call the standard error in this case. The standard deviation of the possibilities for the total at the end. Right? The standard deviation. But when you look at list of numbers, you just call it the standard deviation. But here what we are looking at is actually different estimates, right, for the total gain. So in that case, because it's not a single number, it's sum of single numbers, total of several numbers is one number here, right? And this is again a total of several numbers. So that number, total number, is called a certain called statistic. Right? So this is one possible value for that statistic. Right? So Tn is equal to x1 plus x2 plus x3 plus up to xn. So each of these x's are random variables. X1 can be anything in a certain range. X2 can be anything in this case like that. So this kind of thing is called a statistic. So what we are looking at here is different possibilities for that statistic. So when you want to look at the range of possibilities, size of the dispersion of those possible variables, the statistic, we call it the standard error. Right? But mathematically it is the same as the standard deviation of all these possible values. Right? Standard error. So here they have directly given you the formula to calculate the standard error. Standard error is equal to the square root of the number of rows, not the number of rows like for the expected total, it's n times mean of the box. But here standard error for the total Tn is equal to square root of the n times the standard deviation of the numbers in the box. So that's, we can derive it, but in this class there's no derivation, just remember that. So that is actually the standard error of the sum of the rows. Standard error of the sum of the rows. So you can say, for example, standard error of Tn. Standard error of Tn is equal to square root of n times standard deviation of the box. Standard deviation of the values in the box. So you can calculate the likely size of the variation at the, for example, 10 games or 100 games for each of the previous examples. That is how you get some idea about how large can be the actual last value from the expected value. Right? So most of the values are going to be like, most of the possibilities are going to be within roughly, we will later talk about this thing. These totals, for example, if you are playing large number of times, if n is large, this Tn is going to be normally distributed, random variable, we will talk about that later on. And therefore, when that happens, the Tn, that is the total number of total of the rows, n rows, is going to be close to the expected value, right? Roughly 68% of possible values are going to be within one standard error of the mean, within one standard error. That is something called the empirical rule that we have for the normal distribution. Right? So if you play again and again and again and again large number of times, for example, suppose you play 10 times and then end the game, and then you play again 10 times, and if you do that, about 68% of the times you will end up with somewhere between the expected value plus the standard error, or expected value minus the standard error. Roughly 68% of the times you are going to be end up with in that area. So not that large gain or not that large loss. Roughly 95% of the times you are going to end up with the expected value plus 2 times standard error, or expected value minus the 2 times standard error. So in that area, almost all the times you are going to be between mu expected value plus 3 times standard error, or expected value minus 3 standard error. So that's how it gives you some idea about the possibilities. Right? Roughly 16% of the time within 1 standard deviation from the expected value at that point. That is if the n is large actually. This rule will not be very accurate. For example, if n is the number of times you play is 10 or something. But if you play more than roughly 30 times, if n is larger than 30, usually this rule is going to be correct. Right. So just an example, standard error. Actually, this is explaining the difference between the two words, standard deviation and standard error. As I mentioned earlier, when you look at the standard, the dispersion of the box, so there are a few numbers, x1, x2, x3, up to x6 or something. So you are getting this some measure of the dispersion of those individual numbers. In that case, we call it the standard deviation. Right? But when you look at the gain, in that case, we are looking at when we are drawing one number, so we denote it by x1. We are drawing another number from this box, we denote it by x2. Right? Like this, you do maybe 100 times. So this is going to be, this is what you call a statistic. Right? If you just take one, that x1 is just a single random variable. For a single random variable, we talk about standard deviation. Right? If you are talking about, for example, this is Tn. Tn is a function of several random variables. That is called a statistic. Right? So මේ ටික ඔක්කොම ගත්තට පස්සේ තමයි එක වැලියු එකක් Tn එකට එන්නේ. Tn එකක් හදාගන්න x අගයන් 100ක් ඕන. එතකොට ඒකෙන් එකක් එනවා. එතකොට ඒක දිහා බලාගෙන අපිට බෑ ඩිස්පර්ෂන් එක ගැන කතා කරන්න. මේ වගේව නැවත නැවත කරලා බලන්න වෙනවා. අපි Tn, we have to have several Tns to get idea about the dispersion of Tn. එතකොට ඒකේ එන්නේ ඒන variation එකට තමයි අපි කියන්නේ standard error. Right? So standard error is the word to talk about the dispersion of some statistic, right? So that means you do it 100 times, get one value, and then do it again 100 times. Like you are not doing this, but you have, in order to explain this, you have to assume that you do it. So if you do it again and again and again, let's say 10,000 times, you will have 10,000 values for this quantity. Each 10,000 will have 100 x's. So now if you look at the standard deviation of those 10,000 values, we call it the standard error. Standard error. Right. So let's look at this example. Oh, 1 hour. Shall we take a small break?